Hello friends, good morning. Welcome to our chemistry class. Today we are going to continue our class on F block elements. I think this is part 10. Okay friends, before going to start today's class, I would like to ask a question based on previous class. Okay friends, now I will ask you a question and just try to answer that question in the comment box friends. Okay friends, now I am asking the question. Okay, see, cerium plus 3 is oxidized to cerium plus 4 and it can be precipitated as basic salt or hydroxide. Okay, this is the statement actually. See, cerium plus 3 is oxidized to cerium plus 4 and this cerium plus 4 can be precipitated as basic salt or hydroxide. No, okay, and now I am asking the main question based on this. Okay, see, cerium plus 3 is oxidized to cerium plus 4 with the help of which reagents or which oxidizing agent? Just mention the chemical formula of that particular oxidizing agent responsible for the conversion of cerium plus 3 to cerium plus 4. Okay friends, hope you understood the question. Okay friends, let us start today's class. Now we will discuss about magnetic properties. Okay, let us see. Actually these magnet means here actually I have collected only the most important properties friends. That's why I am doing a separate video on the magnetic properties. Okay friends, see, first point, see, 4f electrons are responsible for strong magnetism exhibited by metals and compounds of lanthanoids. We know that, see, here the electrons which are present in the 4f orbital, okay, we know that the lanthanoids they show strong magnetism. We know this, okay, they can exhibit strong magnetism. Okay, they can means what? Means metals and compounds of lanthanoids. Okay, metals and compounds of lanthanoids exhibit strong magnetism. Okay, and this strong magnetism is due to the electrons present in 4f orbital. Okay, I hope you understood. Next, second point, and this is also important point friends. See, in the incomplete 4f subshell, okay, see, here we are taking a subshell, that is 4f subshell, and here it is not complete, that means it is incomplete 4f subshell. Okay, here the magnetic effects of the different electrons do not cancel out each other as they do in a complete subshell. See, if we take a complete subshell, then there the electrons will cancel out each other, we know. Okay, in a complete subshell electrons will cancel out each other, whereas in case of incomplete 4f subshell the magnetic effects of different electrons do not cancel. Okay, and this factor, which factor? Here the electrons are not cancelling, no, so and this factor gives rise to interesting magnetic behavior of these elements. Okay, we know that here the elements show strong magnetism, and also we know that here it exhibits magnetic behavior of the elements. Okay, here the magnetic behavior of the elements is due to that here the different electrons do not cancel out each other. Okay, okay, next, see friends, here mostly these 3 points are based on the temperature. Okay, rising the temperature, lowering the temperature, like that. Okay, the points which are related to temperature, or really I am telling you that these points are most important friends. Okay, okay, let us see. See, at high temperature all the lanthanides except lutetium or paramagnetic, very important friends. Okay, at high temperature, okay, at high temperature all the lanthanoids are paramagnetic except lutetium. Okay, this exceptional point we had to remember. Okay, and this paramagnetism shows strong anisotropy. I hope that you have idea about anisotropy friends. If you have any confusion or doubt about the anisotropy, just comment in the comment box. I will try to make a separate video on anisotropy, friends. Okay, focus on this. Okay, at high temperature, all the lanthanoids except lutetium are paramagnetic, and this paramagnetism shows strong anisotropy. Okay, this is at high temperature. Next, as temperature is lowered, so whenever we lower the temperature, this paramagnetic means this paramagnetism becomes antiferromagnetic. Okay, very important, friends. Okay, at high temperature it is paramagnetic. At low temperature means as the temperature is lowered, they become antiferromagnetic. Okay, antiferromagnetic. As temperature still lowered, okay, here the temperature is just lowering, but we further means whenever we further lowers the temperature, then what will happen means series of spin rearrangements, okay, which may or may not be in conformity with regular crystal lattice. Okay, what means, see, if the temperature is still lowered means the spin arrangements may not be conformity with regular crystal lattice. Okay, means here regular crystal lattice may not be present like that. Okay, as the temperature is still lowered, series of spin arrangements may or may not be conformity with regular crystal lattice. Okay, next, see, finally at a still lower temperature, okay, final temperature this is, okay, finally at still lower temperature becomes ferromagnetic. Ferromagnetic means what? They show strong magnetic behavior like iron. Okay, see, these points are just based on the temperature, friends. Okay, at high temperature all the lanthanoids are, okay, all the lanthanoids are paramagnetic, okay, except lutetium. Okay, as temperature lowered, they become antiferromagnetic. Okay, paramagnetic becomes antiferromagnetic. As temperature is still lowered means the spin arrangements may or may not be in conformity with regular crystal lattice. Okay, finally at still lower temperature they become ferromagnetic, means they act like strong magnet like iron. Okay, next, see, some of the metals have saturation moments greater than iron, cobalt or nickel. Okay, some of the metals or some of the lanthanoid metals have the saturation moments, and the saturation moments of these metals are greater than iron, cobalt or nickel. Okay, what is this saturation moment? See, saturation moment means magnetism absorbed when all magnetic moment of ions are aligned. Okay, see, whenever all the magnetic moment of ions, okay, whenever the magnetic moment of ions are aligned, okay, at that point whenever the magnetism is absorbed, that moment is said to be saturation moment. Okay, see, some of the metals have saturation moments greater than the